So, hello everyone. Today we are going to learn modal analysis. Okay, so what you need to do once you open the Ansys Workbench, you need to drag and drop this model part into the this profile, okay, or this symmetric project schematics, and then you need to first decide the geometry material which you are going to use. So, if you click this, double click. If you double click this, okay, see structural steel is showing over here. So if you want to add the new material in it, what you can do is you can go to this engineering data. Okay, so in this engineering data you can go to just projects, sorry, fine, and okay, so now you can see only structural steel is available over here. Okay, fine. So now what we can do is filter engineering data. Okay, and now just engineering data sources. From here you can drag and drop, or from here you are having different types of materials which needs to be considered, or you can just consider this as the material library. So in this, select general materials. Once you select the general materials, different types of material will be highlighted over here. Based on your requirement you can select any material. Okay, right. Let's for this case I will select aluminum alloy. Okay, so what I need to do is I need to click this plus button, add. Okay, aluminum alloy, I need to click this. See, it has been added to our system now. So if I go to this engineering data again, or filter data. Okay, you can see the two materials are being visible. So I want aluminum to be used as my reference material. So what I need to do is I need to suppress this. Structural steel need to be suppressed. So once I click this, it is going to be suppressed. Okay. Now again go to the project schematics. Now the aluminum is selected as a reference material. Okay. Now go to the geometry. Click right button on the mouse and then go to space claim or design modeler. Let's we will for this drawing, or for this um, simulations, let us just use design modeler. Okay, so once the design modeler gets opened, fine. Once the design modeler get open, now we need to draw the geometry. So I need to select one plane. So let's say I'm selecting a plane of XY. So if I click this, and if I select this option, see, look at face or plane or sketch. So now the front view of of XY plane can be observed. Now I want to draw the geometry. So what I need to do is I need to click this sketching. Once I do the sketching part, I need to draw a line, and I need to generate a horizontal line over here. Okay, let's say I'm just randomly drawing a horizontal line. Okay, I don't have dimensions, so I need to define the dimensions in it. Okay, so if I go to here and if I draw the dimensions, see, dimensions horizontal line. So if I click this, if I click this and just a second. So now I can define the dimension. So see here h1. And this is in meters. So all the units are in meters, right? So let's say this is 1 meter length. Okay. So now this is something 1 meter line. Okay. And once this is done, okay, I will just press the generate button. So now there is one line generated over here. So what I need to do is I need to convert this line into some specific cross section, or I need to convert this line into some specific geometry. Okay, so now what is to be done is this is just a line. Okay, so we have generated a sketch, and this sketch need to be converted into, this is just a sketch and it needs to be converted on the line. So now it is converted into a line. Okay, once I do the generate button, now it is a line. And now what we can do is I can define a different cross sections of this geometry. Okay, so what I will do is initially I will consider a rectangular geometry. Okay, rectangular cross sections, and let's say so 0.1 meter, and similarly this is also 0.1 meter. Okay, so now this is something zero point 0.1 meter square geometry which we are going to assign this. So once if I do it, now this is the assigned geometry which is given to that specific line. Okay, so once I do it, just generate it. So now the geometry is generated. Okay, if I want to see this, just observe this iso geometry. Okay, this is isometric geometry which is showing over here, right? Okay, now once this is defined, if I go to model, go to edit. Now once the geometry is decided, we need to do the meshing and then define all sort of boundary conditions for solving the problem. So now this is the meshing window which appears from the workbench once you click meshing. Okay, and then the geometry is going to be represented over here. Okay, so let's say this is your line which is showing over here. See, if I click this, this is your 1 meter line. Okay, if you want to observe the shape of the geometry, just go to display and define the cross section. And once you click this, okay, so what I need to do is initially I will define the geometry, I will define the cross section, that is rectangle. Okay, and then I need to do the assignment of a material, that is aluminum alloy. Okay, and now if I define the cross section, see, now you can just see the rectangular cross section which we have defined earlier. Okay, now the next step is to just generate a mesh. Now you can see this is a coarse mesh which is generated. Okay, you can improve the mesh, but for me it's not required because my intentions is just to understand the free vibration characteristic of this 1 meter beam. Okay, now what I'm going to do is I will add the design boundary conditions. Okay, let's say this end is fixed. Okay, so if a body is having a fixed support, if the body is having a fixed support, okay, if the body is having a fixed support, then Just hold on for a second. Okay, just give me a moment. So, okay, so this is the cross section actually, which is assigned to the line. Okay, so if I want to define the cross section on this, it is not possible. So what I will do, I will just make it again a line. Okay, and then what I will do is I will define a fixed support at the end. So what I need to do is I need to just select this vertex. I will select this point and I will apply. Right. So this is fixed support. What do you mean by fixed support? Fixed support, that means x-axis, y-axis, z-axis. There is no relative movement as well as there is no rotation in x-y-z axis. That is your fixed support. Now the next part is at the end of this 1 meter I need to that means we have fixed one of the support, and now we need to observe that what sort of deformations, that means how, if I just solve it, okay, let's say just solve it. So now the vibration frequencies are going to be evaluated. Okay, see, it is calculating the vibrations which is generated, and that too also known as modal vibrations. Okay, and this is done in that the environment temperature. So based on that, a tabular data will is going to be generated over here, which defines the frequency of vibration of this specific geometry. Okay, so you can observe this is the natural frequency of vibration. Now if I define the cross section, now see, this is your cross section, and if I select all this and if I do the create mode shape results, then all sort of vibrations are going to be observed over here. Okay, and then again in this solution you need to go and solve it again. So based on this natural frequencies, now all modal vibrations are going to be generated over here. So this is your first modal frequency. Now this is your second modal frequency, third modal frequency, fourth modal frequency, fifth modal frequency, and sixth modal frequency. Okay, so if I just simulate it, see, this is the sixth frequency. That means how the geometry is going to be moved in forward and backward direction. Similarly, if I click this deformation fifth, the frequency is going to move the body in this way. Okay, similarly, the frequency, this fourth number frequency, the model is going to vibrate in this pattern. If you consider this deformation 3, this is how the model is going to vibrate. Okay, you can see. Okay, so this is how you find out the modal frequency for any modal vibrations. Okay, I hope so this is clear to everyone. Thank you.